Hey, hi my dear students, welcome back again. Hope you all are doing absolutely great. In this lecture, we are going to solve JEE Main's previous year questions from the chapter of functions and from the years 22, 23 and 2024. Let's start with question number 1. Coming to the first question, they have given two sets and the total number of 1-1 functions, f mapping from A to B. So first we should know the formula to find number of 1-1 functions if f mapping from A to B. F is a function mapping from A to B such that we have number of elements in A is equals to some m, number of elements in B is equals to some n, then number of 1-1 functions from A to B is equals to npm, that is nothing but n factorial divided by n minus m factorial. So this is the formula that we are going to use it. Okay, now let's come back to the question, friends. So they have given two sets, set A, set B. Set A consists of, what are the elements? 1, 3, 7, 9, 11. Set B consists 2, 4, 5, 7, 8, 10, 12. Okay. Then the total number of 1-1 functions, that's fine. But they have given such that f of 1 plus f of 3 is equals to 14. Friends, imagine if they are not asking this particular condition, then total number of 1-1 functions is directly 1, 2, 3, 4, 5, 6, 7. 7p 5. Answer is 7p 5. But they are not asking that to find directly. This 1-1 function should satisfy a particular condition. What is that condition? Let's see. F of 1 plus f of 3 is equals to 14. So, f of 1 plus f of 3 is equals to 14 means, first, if I take 1 as 1 map, let 1 maps with 2, then for sure 3 should map with 12. Why? Because f of 1 plus f of 3 is equals to 2 plus 12, which is equals to 14. Now we'll fix these two. Now remaining we have 1, 2, 3, 4, 5. 5 elements in set B, 3 elements in set A. When we are fixing these two, that means number of 1-1 functions in this case 5p3, which is equals to 60. 5 factorial divided by 5 minus 3 factorial. So 5 factorial by 2, 120 by 2, 60. Clear? So in this case we have got 60 functions. Now we have one more possible case. That possible case is if one is mapping with 4. Sorry, let's reverse this. If one is mapping with 12, and 3 is mapping with 2, we are reversing it. If 1 is mapping with 12 and 3 mapping with 2, then even in that case we'll get one more 60. Clear? Are you getting me, friends? So this is 1, 2. See, 1 mapping with 2 and 3 mapping with 12. In this case we have got 60 1-1 functions. Second case is we mapped 1 with 12 and 3 with 2. In this 60 more. Plus any other possibilities we have to check. Now if you see this, friends, if f of 1 is equals to 4, and f of 3 is equals to 10, 1 mapping with 4, 3 mapping with 10, even in this case we'll get 60 more. Vice versa, 1 with 10, 3 with 4, we'll be getting 60 more cases. So these are the 4 possible cases we get. That means 60 into 4, 6 4 is 24. Total 240 1-1 functions from A to B such that f of 1 plus f of 3 is equals to 14. Have you understood, friends? Now they are not asking us to find number of 1-1 functions directly. They have given a condition. That condition should satisfy and remaining elements should map. Each element of A should map with only unique element, distinct element in set B. Clear? So first what we do, we have satisfied the given condition. When we satisfied the given condition, that means 1 mapping with 2 and 3 mapping with 12, one case, the remaining possible 1 functions in that case. See, when 1 maps with 2 and 3 maps with 12, this can be mapped in only one way. 1 into 5p3, 60 cases, plus reverse, 1 with 12, 3 with 2, 60 more. Next, 1 with 4, 3 with 10, 60 more. Again, reverse. So total 64s, 240 functions, 240 functions we get from A to B. Clear? Second question. F comma G mapping from R to R such that f of x is equals to mod of x minus 1 and g of x is equals to e power x if x greater than or equals to 0 and x plus 1 if x less than or equals to 0. Friends, I have taken very good questions from composite functions. As majority of the students are having facing difficulty in evaluating a composite function, so I came up with good questions from composite functions. Okay, now let's see how do we get the function f of g of x. F of g of x, we have f of x is equals to mod of x minus 1. So f of g of x will be same. In place of x we put g of x. Clear? Now we'll try to look after g of x. See, g of x is a function. If x greater than or equals to 0, g of x is e power x. Okay? So if x greater than or equals to 0, g of x is e power x. We put e power x here. Mod of e power x minus 1. When x is greater than 0, e power x will always be greater than or equals to 1. Clear? So 1 minus 1, that is, if x is greater than or equals to 0, e power x minus 1, mod of e power x minus 1 is always positive. Something inside mod is always positive. That means it is directly e power x minus 1. Clear? Very good. Next. If x less than or equals to 0, what will be our if x less than or equals to 0? Oh my god. Okay, if x less than or equals to 0, what happens? Let's see. If x less than or equals to 0, what happens? We put x plus 1 in place of g of x. X plus 1 minus 1. X plus 1 minus 1, we have got mod of x plus 1 minus 1. 1 cancel. We have got mod x. Now if x is less than or equals to 0, mod x is minus x, friends. Clear? Mod x is equals to minus x. Okay, now we have got f of g of x. We have to determine whether it is 1 function or onto function, neither 1 or nor onto. Let's see. Now clearly, when x less than or equals to 0, minus x is always positive. If x greater than or equals to 0, e power x minus 1 is always positive. So in range, you are getting only positive real numbers. In range, you are getting only positive real numbers. Okay? Clear? So in that case, that means it is clearly not onto function. It is an into function. Okay? Why? Because here the function we have defined from R to R. In R, as we are getting only set of positive real numbers, so this function is clearly not onto. Hence, this function is neither 1 nor onto, which is option B. Clear? Defining f of g of x, till there we need good support. After that, whether it is 1 or onto, we can just directly say. Or one more thing, by graph also. See this, friends. By graph also, we know e power x minus 1 graph. The graph of e power x minus 1 is starting with exponential graph, like this it will be. And y is equals to minus x graph is a straight line. This is what y is equals to minus x graph, and this is y is equals to e power x minus 1. Now look at this graph. This graph is nothing below x-axis, so clearly it is not onto. Okay, now coming to 1 function or not, we can decide whether a function is 1 or not by horizontal line test. Yeah, now if we draw a horizontal, this horizontal line is intersecting at more than 1 point, hence it is not a 1 function. So hence the answer is neither 1 nor onto. Clear? Next question, friends. F of x is equals to x square plus 2x minus 15, x belongs to R, divided by something. Is 1 and onto or not 1 something. Okay, let's see this, guys. Same story again almost. Now f of x is equals to, we have got x square plus 2x minus 15. This we can write it as x square x plus 5 into x minus 3. We can factorize directly. Clear? Divided by x square minus 4x plus 9. Divided by x square plus 4x minus 9. Can we factorize denominator? No. Now see friends, clearly what is f of minus 5? 0. What is f of 3? Also 0. So for both minus 5 and 3 we have same image, hence it is not 1 1. Clear? Hence it is not 1 1. Now check whether it is onto or not. For that we have to find range ma. So how do we find range? By quadratic by quadratic. I have given you many majority of the times in class itself. Quadratic by quadratic. Y is equals to quadratic by quadratic. How do you find the range of the function? So just take f of x as y friends. Now y is equals to x square plus 2x minus 15 divided by x square minus 4x plus 9. X square y minus 4xy plus 9y is equals to x square plus 2x minus 15. Now from here what to do? We have to express it as a quadratic equation in only x. So x square of y minus 1, next plus x into minus 4y minus 2 plus 9y plus 15 is equals to 0. Now as it is a quadratic equation in only x, so as x belongs, they have given x belongs to capital R, that means roots will be for sure real. Roots will be for sure real. So the discriminant of this equation is always greater than or equals to 0. What is discriminant? B square minus 4ac, that is 4y plus 2 whole square minus 4 times y minus 1 into 9y plus 15. For sure it will be greater than or equals to 0. We can take 2 common, so 2 square 4, 4 into 2y plus 1 whole square minus 4 into y minus 1 into y plus 15, 9y square y into 15y minus 9y plus 6y minus 15 greater than or equals to 0. So 4 into 2y square is 4y square plus 1 plus 4y minus 9 4s are 36y square, 6 4s are 24y minus 60 greater than or equals to 0. So 4 4s are 16, 16 minus 36 which is minus 20, minus 20y square, 4 1s are 4, 4 minus 24 which is minus 20y. Clear? 4 4 16 minus 36, 4 1s are 4, 4 minus 24 minus 20. Sorry, this is not y, no. 4 4s are 16, 16y minus 24y which is minus 8y. Next 4 1s are 4, 4 plus 60 which is 64 greater than or equals to 0. Now when we multiply both sides with negative, what do we get? Plus 20y square plus 8y, 20y square plus 8y minus 64 less than or equals to 0. Take 4 common friends, 5y square plus 2y minus 16 less than or equals to 0. So clearly now friends, look at this. This is a quadratic equation in y. For sure the range will be subset of R. Just by factorizing this we get it. Okay. So now actually they have given the function mapping from R to R. It is a real function. Function mapping from R to R. So are we getting complete set of real numbers in this? No. When we factorize, when we do it by using wavy curve method, we can get this. We can get something like y belongs to something to something in this way, closed brackets. So as this area is not including the complete set of real numbers from minus infinity to plus infinity, hence range is not equals to the codomain. Hence the function is neither 1 1 nor on 2 friends. It is neither 1 1 nor on 2. Okay, next question. F of x is equals to one of the most easiest question which was asked in 2024 ma. See, 7 minus, see, you know, sine 5x always ranges from -1 to +1. Okay, even minus, when you multiply with negative, that also will be from -1 to +1. Now if you add 7, so 7 minus 1 less than or equals to 7 minus sine 5x is always less than or equals to 7 plus 1, 8. So that is 6 less than or equals to 7 minus sine 5x less than or equals to 8. When you take reciprocal, friends, 1 by 8 will be less than or equals to 1 by 7 minus sine 5x less than or equals to 1 by 6, because when you take reciprocals, inequality sign will be interchanged. So that means, and this is what, so hence what is the range of our f of x? Range of f of x is, sorry, from 1 by 8 to 1 by 6. Range of f of x will be now from closed 1 by 8 to closed 1 by 6. Closed 1 by 8 to closed 1 by 6. Answer is option C. Clear? Simple. Just range of, we have taken the range of sin x. Sin x always ranges from -1 to +1. Even sin 5x also ranging from -1 to +1. We have got from that ma. Let t be the greatest integer less than or equals to t. Okay, that means step function. Let a be the set of all prime factors of 2, 3, 1, 0. What are all the prime factors of 2, 3, 1, 0? Prime factors of 2, 3, 1, 0. For sure 2, 3, 5. Do we have 7? 7 3s are 21, 21. So 7 is also there. Next, 11 is also there. That's it. So 2, 3, the set of all prime factors of 2, 3, 1, 0 or 2, 3, 5, 7, 11. Now this is our domain. We have a function f mapping from a to z only, be the function f of x is equals to step of log x square plus step of x cube by 5 to the base 2. Okay, then number of functions 1 to 1 mapping from a to the range of f. We have to find range of f ma. For that, each input, first we will find f of 2. What is f of 2? F of 2 is equals to step of log 2 square 4 plus 2 cube 8 by 5. Step 8 by 5 is step of 8 by 5 1 point something, so 1. Clear? Now 4 plus 1 is 5. 5 we can write it as this, we can write it as again step of log 2 square plus 1 to the base 2. So for sure it is step of this is nothing but 2 point something, because log 2 square to the base 2 value is 2 plus something. So 2 point something, step of 2 point something is 2. Clear? So f of 2 is 2 now. In the same way, let's find f of 3. F of 3 is equals to step of log to the base 2 3 square 9 plus 3 cube 27 by 5, that is 5 point something. Step of 5 point something is 5. Okay, so 9 plus 5 is 14. 14 means we can write it as 2 cube 8, 2 power 4, 16. So for sure it is log 2 cube plus something, correct? 14 means you can't write it as 2 power 4. 2 power 4 is 16. So log 2 cube plus something. Log 2 cube is 3 point something. Step of 3 point something is 3 now. I am writing it directly, friends. Next, f of 5. F of 5 is equals to same story, log 5 square, which is 25. 5 cube 125. 125 divided by 5, which is 25 again to the base 2. Log 25 plus 25 is 50. 50 means we can write it as 2 power 4 16, 2 power 5 32, 2 power 6 64. So 2 power 5 plus something, that means 5 step of 5 point something, so which is clearly 5 only. Okay, next f of 7. F of 7 is equals to 7 square 49, 49 plus this, so the value is just greater than 64 ma, 64 plus something, 2 power 6 log 2, 64 is 2 power 6, so log 2 power 6 is 6 point something, that is nothing but 6. Okay, next f of 11. Oh, 11 is 11 square 121. 121 plus something means we have 2 power 6 64, 2 power 7 128, 2 power 8 512. So 2 power 8 plus something, that is nothing but plus 8. Okay, now we have the range. What is the range of f now? Range is 2 3 5 6 8. 2 3 5 6 8. This is our range. Domain is 2 3 5 7 11. Now number of 1 functions npm. How many? 1 2 3 4 5. 1 2 3 4 5, which is 5 factorial ma. 5p5, which is 5 factorial. Answer is 120. So the only important thing is finding the range of the given function here. Clear? Next question. Let f of x is equals to minus a, then something like not composite function. Okay, first we have to define f of mod x and mod of f of x. What is f of mod x? F of mod x. F of x is minus a if x less than 0. Now mod x, can mod x be less than 0? Never. So it is only f of x is equals to x plus a. If 0 less than mod x less than or equals to a means, mod x less than or equals to a means, we'll write two cases. See, mod x less than or equals to a means we'll split it into minus a less than or equals to x less than or equals to 0 and 0 less than or equals to x less than or equals to a. Okay, so now first case we'll split it minus a less than or equals to x less than or equals to 0, that is x plus a, and in this case mod x plus a, when x less than 0 it is minus x plus a. I hope it is clear, friends. I hope it is clear. Yeah, see, f of x is equals to mod x plus a. Now if x less than 0, mod x is minus x, so we get minus x plus a. Now second case is 0 less than x less than or equals to a. In that case mod x is mod x plus a, x is positive, so x plus a. We have got f of mod x function. Now what is mod f of x? Mod f of x is directly applying mod to this. Mod of minus a is a. Okay, now next what do we need? Mod of x plus a, when x is anyhow positive, no, so it is on also x plus a only now. Okay, now what we need, this is from minus a less than or equals to x less than 0, and this is from 0 less than x less than or equals to 0 less than x less than or equals to a. Now what they are asking, friends? What they are asking? They are asking us to find g of x. G of x is a function such that it is equals to f of mod x minus mod of f of x whole by 2. Okay. Okay. First case, from minus a to 0, minus a less than or equals to x less than or equals to 0, f of mod x is minus x plus a. Minus x plus a minus a is minus x. Minus x by 2 is, so this is clearly minus x by 2. Clear? Next, x plus a minus x plus a 0. So for all the values from 0 to a, it is 0. Then this function is clearly neither 1 1 nor onto function. Neither 1 1 nor onto function. Why? Why? Because see, from minus a to we are getting only positive numbers and we are getting only 0. So hence it is neither 1 1 nor onto function. Neither 1 1 nor onto function. Okay. Next question. So the only important thing that here it is, how do we find f of mod x and how do we find mod of f of x? Okay. Next question. F mapping from R to R, G mapping from R to R again defined as, they have given f of x and they have given g of x, friends. Same question again, they are asking us to evaluate G circle f of x. So G circle f of x is nothing but g of f of x, friends. Okay. Now what is g of f of x? G of f of x is g of x is, so g of f of x is nothing but f is equals to f of x if f of x greater than or equals to 0 and e power f of x if f of x less than 0. Now you focus on f of x. F of x greater than or equals to 0 means in which case f of x? In both the cases. So that means clearly from this case G circle f of x is equals to G circle f of x is equals to e power minus x if x is less than or equals to 0. If x less than or equals to 0, e power minus x. Next, from 0 to 1, 0 less than x less than 1, it is x. From 0 to 1, it is x. Next, if x greater than or equals to 1, it is log x. If x greater than or equals to 1, it is log x. Now, let's determine whether it is 1 1 function or onto function or neither 1 1 nor onto function. Clearly friends, it is a composite function. See, e power minus x always positive, 0 to 1 always positive, x is always positive, log x to the base e when x greater than or equals to 7. So it is the range is not equals to codomain, hence it is clearly not onto. In the same way, it is not 1 1 function, hence this function is neither 1 1 nor onto function. Okay. Or if you wish to get by using graph also, it is fine. Now by using graph, how do we find? 0 to 1, it is y is equals to x. See, less than or equals to 0, e power minus x graph. E power minus x graph less than or equals to 0. That means e power minus x. If less than e power minus x graph is, we know e power x graph. Now e power minus x graph is nothing but for mine. So this will be something like this. E power minus x graph it is. Clear? Now this is the graph we need for e power minus x, x less than or equals to 0. This is our e power minus x. Y is equals to e power minus x. Okay. Next what else we need? 0 to 1, it is just y is equals to x. 0 to 1, it is y is equals to x. Okay. Next, log x to the base e if x greater than or equals to 1. Log x graph we know, this is what the graph of log x function. Log x function is an increasing function. It intersects x axis at a point 1, 0. Okay. Now if you see this friends, if I draw a horizontal line, denominator it won't be. Why? Because nothing will be below x axis. Now if I draw a horizontal line, this horizontal line for sure it intersects more than one point, hence it is clearly neither 1 1 nor onto function. Okay. Next, sometimes graph will also help us. So please make sure that you have a good knowledge in graphs also. In session, in class, in our general regular classes, I have already given the graphs of all the different functions, all the functions, modulus function, step function, floor function, fractional part function, y is equals to 1 by x function, xy is equals to k function. Clear? Y is equals to x square function, all parabolas or ellipse, all circle, different forms. Y is equals to x cube graph. Apart from that, I have also given graph plotting. So with those, please make sure you are having a clear idea about all the graphs. Next question. If the domain of the function f of x is equals to root x square minus 25 divided by 4 minus x square plus log of x square plus 2x minus 15. Acha, they have given already domain ma. We just, if we can find a domain and compare that with this, we'll be getting the values of alpha and beta. So chalo, first one is anyhow x square minus 25, for sure it is greater than or equals to 0. Acha, so x plus 5 into x minus 5 is greater than or equals to 0. So x belongs to minus infinity to minus 5 union 5 to infinity. Denominator 4 minus x square not equals to 0. So x not equals to plus 2 comma minus 2. Luckily these two are not in this, so no need to exclude them. Next, this is one equation. Second equation is x square plus 2x minus 15 should always be greater than 0. So this we can write it as x plus 5 into x minus 3 greater than 0. So x belongs to minus infinity to minus 5 union open 3 to infinity. This is second equation. Now taking the intersection of these two, the common region. Our domain is the common region. So what will be the common region? Minus infinity to minus 5 open brackets union closed 5 to infinity. So by comparing this with this, alpha is equals to minus 5, beta is equals to plus 5. Now they are asking, what they are asking? Alpha square plus beta cube. Alpha square plus beta cube is equals to 25 plus 125, which is 150 is the answer. Clear ma? So the answer is 150. Simple question, just based on domain and all. Next question. F of x is equals to x minus 1. If x is even, x is odd, 2x, x belongs to n. If for some a belongs to n such that f of a is equals to 21, then limit extends to a minus. Acha, a minus means just left hand limit at x is equals to a. Mod x cube divided by a minus step of x by a. Acha, this is not fractional part, this is just brackets, okay? Don't get confused that these brackets are flower brackets, so it is some fractional part. No, if it is fractional part, they'll give you that, okay? Now, they are asking how many times f of a. We don't know what is a. A can be even, a can be odd. Why? Because here the function is defining in two possible ways based on the input. If the input is even, it is behaving one way. If the input is odd, it is behaving in another way. So that means we have to take it in two cases. We have to take it in two cases. Case 1. Case 1. If a is even. Case 2, if a is odd. First I'll check with this. If I get result, fine. I no need to check. If I won't get result, then I'll go for a is odd. Okay. Now if a is even first. Now what will be f of a? A is even means a minus 1. F of a is a minus 1. Okay. Now what is f of a? See, f of a is a minus 1. When a is even, a minus 1 will be odd. So input is odd. If input is odd, it is 2 times of a minus 1, which is equals to 2a minus 2. Now they are asking once more, f of a, this will be equals to, see, this is even now. So when x is even, f of x is x minus 1, that is 2a minus 2 minus 1, which is 2a minus 3. So clearly f of a is 2a minus 3. They have given this as 21. So 21. 2a is equals to 24. A is equals to 12. Clearly I have got a is equals to 12. So chalo. Now what they are asking? Limit x tends to 12 minus just less than 12. 12 mod of 12 is 12. 12 cube. Sorry. 12 cube is anyhow 1. My God. 12 cube. Okay. Divided by 12. Acha. First what we do? We'll just mod x whole cube by 12 minus step of x by 12. Now see this, friends. 12 cube by 12 is 12 square minus, if x is just less than 12, just less than 12 by 12, for that step function is 0 point something for sure. Okay. Step of 0 point something is 0. 12 square is 144. As I have already got the answer, no need to check for case 2 ma. No need to check for case 2. So answer is 144. Clear? Here we are supposed to split into 2 cases. Luckily I have got a value. I have taken a as even. I have got a 12. So it is all for me. Whatever the conditions that I have taken, even the result is also verified true. Suppose if I get a equals to 11, that means this case is wrong. So I have to go for second case. Okay. Next question. The function f mapping from n minus 1 to n defined by f of n is equals to the highest prime factor of n. So f of n is nothing but the highest prime factor of n. Okay. Now they are asking whether it is 1 1 or on 2 or neither. Friends, what is f of 2? 2. F of 4 is again 2. F of 8 is again 2. So clearly it is not 1 1. Clearly it is not 1 1. Okay. And what about range? In range you get only set of prime numbers. But they have given, so range is not equals to codomain, hence thus this function is clearly neither 1 1 nor on 2. Two elements are having, more than 2 elements are having same image, so it is not 1 1, range not equals to codomain, hence it is not on 2, hence the given answer, hence the required answer is it is neither 1 1 nor on 2. Next question. F mapping from R minus of minus 1 by 2 to R and G mapping from R minus of minus 5 by 2 to R be defined as f of x is equals to, friends, they have given f of x and g of x. What is f of x? F of x is equals to 2x plus 3 divided by 2x plus 1 and g of x is equals to mod x plus 1 divided by 2x plus 5. Then the domain of f circle G. Array yaar, friends, it is so simple. F of g of x. F circle G is f of g of x. So the domain of f of g of x is nothing but domain of g of x only. Clear? Domain of g of x only. What is the domain of g of x? R minus of minus 5 by 2, which means the answer is directly R minus of minus 5 by 2. Direct question. Okay? Next one. If f of x is equals to 2 plus 2x for minus 1 less than or equals to x less than 0 and 1 minus x by 3 for 0 to 3, g of x is minus x and x, then the range of f circle, again composite function, f circle g of x, that is f of g of x. F of g of x. Okay. Now we have seen anyhow how do we define f of g of x. You can do it in that way. Another way of determining f of g of x is by graphs. See this, friends. See this. Now first I will go with f of x graph. This is the graph of y is equals to f of x. F of x is equals to 2 plus 2x for minus 1 to 0. This is minus 1. This is 0, 1, 2, 3. Next 1, 2. Now let's see this. When x is equals to minus 1, f of x is 0 ma. Clear? If x is equals to minus 1, f of x is 0. Now if x is 0, so x can't take 0, but if x is 0, it is approaching to 2. So it is somehow like this. I have taken halo circle only. Okay, this is the graph of the function for x for -1 to 0. Next 0 to 3. If x is 0, f of x is 1. If x is 3, f of x is 1 minus 3 by 3. 1 minus 1. F of x is 0. So this is the graph of the function y is equals to f of x in the given range, in the given interval. Okay. Now in the same way, let's find the graph of y is equals to g of x. Y is equals to g of x graph also. We are finding it. Let's see the graph. First, g of x is from -1, -2, -3, 0, 1. Okay. Now see, g of x is equals to minus x. Minus x means 1, 2, 3. G of x is equals to minus x from -1 to 3. So minus x means we know already the graph of y is equals to minus x. This is how it will be. Okay. Y is equals to minus x graph. And from 0 to 1, it is the graph is this one. Okay, this is the graph of y is equals to f of x, and this is the graph of y is equals to g of x. Now let's see this, friends. What they are asking, f of g of x. What is f of g of x in generally composite function? For f of g of x, first we take input as x. Then that input will be the input to g of x. This g of x will be the input to f of g of x. Correct na? Okay. Now for g of x we take input as these two. Correct now? So if x belongs to -3 to 0, first case, if x belongs to -3 to 0, -3 to 0, what is g of x? G of x is from 0 to 3. G of x is ranging from 0 to 3. Okay. Now if this as input, if g of x takes from 0 to 3. Now f of g of x means f of g of x. So for f with 0 to 3 as input, it will be ranging from where to where? It will be ranging from where to where? For 0 to 3, it will range from, clearly it will range from closed 0 to 1. Clear? For x belongs to 0 to 3, f of x will be ranging from 0 to 1. Okay. Next case is from 0 to 1. If x takes from open 0, open or closed, open 0 to closed 1, g of x is again open 0 to closed 1 only. That is also open 0 to closed 1. Open 0 to closed 1. For 0 to 1, now from 0 to 1, what is the range of f of x? Let's see. 0 to 1, range of f of x is, when x is 1, 1 by 3. 1 minus 1 by 3 is 2 by 3. So this portion is, this height is 2 by 3 now. So clearly the range is from open 2 by 3 to closed 1. Now friends, we'll take the union of these two. So hence, finally we can say range of f of g of x is equals to closed 0 to closed 1, which is option D. The answer is option D. Okay. Next. Question 13. F of x given. F circle f of x is g of x, where g mapping from r minus 2 by 3 to r minus 2 by 3. Then g circle of 4. Again composite functions only. Friends, I am going to give you one most important formula, important identity that we have in functions is, whenever you come across a function f of x is equals to some ax plus b, divided by cx minus a. Whatever the coefficient of x, if it is minus a here, minus a. Okay. Now for this function, f of x is equals to ex. f of x will be equals to x. I repeat, whenever we come across a function f of x is equals to ax plus b divided by cx minus a, the coefficient of x and the constant here. If you add these two, if you get 0, then f of x will always be equals to x. Clear? If you wish to do, you do. Find, you have already know f of x. Find f of x, you will be getting x. So directly I am taking from here. Now g of x will be equals to x now. Okay. Now they have given g of 4. What is g of 4? So g of 4 is 4. Again g of 4 is 4, which is 4. So answer is one step, which is 4. Clear? This is what very important. This particular step is very important. If f of x is equals to this, then f of x is equals to x. Dear friends, if you wish to verify, please do verify. Find f of x, you will get x. We will do many questions in this way. Many questions. Next one. If the function f mapping from minus infinity to 1 from a to b defined by f of x is equals to is 1 1 and on to. Acha, this is a 1 1 function. And friends, this is exponential function. We know exponential function is always positive. Acha, increasing function. They have already given whether it is increasing or decreasing. But we have e power x cube minus 1 as we have highest power positive. So it is always increasing function. Okay. Now increasing on 1 1 function. So that means clearly if it is increasing, f of minus infinity. So for least you get least, for highest you get highest. F of minus infinity should be equals to a and f of minus 1 should be equals to b. So what is f of minus infinity? When you put x is equals to minus infinity, f of e power minus infinity whole cube is minus e power minus infinity, which is equals to 0. Okay. Next, a is equals to 0. When you put x is equals to minus 1 plus 1, 0, e power 3 you get. So b is equals to e power 3. So finally we got a 0, b is equals to e power 3. Now what do we need? Then the distance of the point p of 2b plus 4. What is the point? 2b plus 4. 2 into e power 3 plus 4 comma a plus 2, which is only 2 from the straight line. So distance from a point to line ma. We got point, we know line, distance from a point to line, perpendicular distance. So distance is equals to mod of, we'll substitute the point in this, 2 times of e cube plus 4, okay, plus 2 into e power minus 3 minus 4 divided by square root of a square plus b square, that is under root 1 plus e power minus 3 whole square. So 4 minus 4 gets cancelled. So friends, clearly it is 2 times of what is this? 2 times of e power 6 plus 2 divided by under root 1 plus e power minus 6 whole by e power 3 we have e power minus 6. If you take LCM, so clearly we get the answer as this one. Simple one. They are just asking us to simplify. Clear? First, you should know this. If it is 1 1 function, that means it is either increasing or either decreasing. Okay. Exponential function now. Exponential function means it is increasing function. So for least input we get least value. For higher input we get higher value. Next. Set A given, set B given, then they are asking us to compare between these two sets ma. First set, you should know friends, for step function, step of x plus integer is equals to step x plus I. Step x plus I, okay. Now from this case, step of x plus 3, step x plus 3 plus step x plus 4 less than or equals to 3, 3 cancel. So 2 times of step x is less than or equals to minus 4. step x less than or equals to minus 2. That means x less than or equals to x less than minus 1. If x is less than minus 1, step x will always be less than or equals to minus 2, correct? So what is x belongs to less than minus infinity to minus 1. This is our set A. Now coming to set B, this is in GP ma, that to infinite GP. Infinite GP is 3 power x into A by A 3 by 10 divided by 1 minus 3 by 10 is less than 3 power minus 3x. So clearly this is equals to, ratio is only, common ratio is only 1 by 10. So 3 power x into 3 by 10 by 9 by 10 whole power x minus 3, sorry, less than 3 power minus 3x, 1 by 3 whole power x minus 3. So 3 power x into 1 by 3 whole power x minus 3 less than 3 power minus 3x. Friends, if you simplify even from here also we are getting x less than minus 1 only. So that means B also minus infinity to minus 1. That means both A and B are equal ma. Set A is equals to set B. Okay. So this is infinite GP. Infinite, solving infinite GP is A divided by 1 minus R. A is equals to 3 by 10. R is equals to 1 by 10. Okay. Good. Next question. Let the sets capital A and capital B denote the range and domain and range respectively of a given function, where roof of x denotes the smallest integer greater than or equals to x. Friends, we have seen step x. Step x is greatest integer less than or equals to x. Here this is roof of x. Roof of x means smallest integer greater than or equals to x. So first we have to understand that this is not step x. This is not step x. This is smallest integer greater than or equals to x. So first we will define. For x belongs to integers, friends, for x belongs to integers, smallest integer of x is always equals to step x. Smallest integer of x is equals to step x. Okay. Next, for x does not belongs to integers, roof of x is equals to step x plus 1. Roof of x is always equals to step x plus 1. Okay. So these two you should make a note of it. Here they have given smallest integer greater than or equals to x, not step x, not box of x. Okay. Now, suppose friends, if x belongs to integers, floor of x is equals to step x. Now when x is integers, step x is equals to x only. Okay. In that case 1 by 0, oh my god. So we are getting not defined. That means clearly x cannot be integer. So the domain of f of x is r minus z. Okay. For no integer it will be defined. Clear ma? Because for x belongs to integers, smallest integer greater than or equals to x will always be equals to step x. Now again when x is integer, step x is equals to x. So step x minus x will be 0. Okay. So domain of f of x. That means this is our set A. Okay. This is our set A. Next, what is set B? Set B denotes the range. What is the range of this function? Let's see now. Now what is f of x? F of x is equals to 1 by square root of, this is anyhow step x plus 1, that is step x minus x plus 1. Okay. So 1 divided by step x minus x is x minus step x is fractional part. So step x, so that is 1 minus fractional part of x. Clear ma? So domain should always be domain. That means square root of something should always be square root of something. So 1 minus fractional part of x. We know fractional part of x will always lie in between 0 to closed 0 to open 1. 1 minus of something. So that means this value for sure it will be less than 1. Okay. So 1 divided by less than 1, 1 divided by less than 1, that means for sure it is going to be greater than or equals to 1. Clear? So range of f of x, oh man, one more thing, x cannot be 0 also, because x should not be integers, no? So we have to take open 0 to open 1. That means this value f of x will only be greater than 1. Therefore range of f of x is open 1 to infinity. Open 1 to infinity. So we have got two sets ma. Set A is r minus z, set B is open 1 to infinity. Okay. Now what they are asking us to find? A intersection B is 1 to infinity minus, yes, when you take the intersection of these two, we have 1 to infinity. From that we exclude set of natural numbers. Yes, S1 is true. Now when you take A union B, what is A union B? A union B means r minus integers union 1 to infinity. We will be getting negative values also, but we don't have negative. So S2 is false. That means only statement 1 is true, friends. Only statement 1 is true. Okay. Next question. F of x is equals to some tan 1 degree x plus log 123 to the base e x into log 1234 to the base e minus tan 1. Majority of the students waste their time by just reading it. But if you have understood, already I have solved a question based on the same. Friends, whenever you come across f of x is equals to of the form some ax plus b divided by cx minus a. The coefficient of x and the constant here, if you add them, if you are getting 0, then that means f of x is equals to x. That's it. F of x will be equals to x. Okay. Now what is f of x? Which is equals to x plus f of 4 by x, which is 4 by x. So they are asking the least value of this by using am and gm. Am is always greater than or equals to gm. So that is x plus 4 by x whole divided by 2 greater than or equals to x into 4 by x. So x plus 4 by x is always greater than or equals to 2 times root 4 is again 2. So this will always be greater than or equals to 4, friends. See, if you know this, then no need to do f of x. It takes much time if you are not knowing this. Next question. The domain of the function f of x is equals to step x square minus 3 times of step x minus 10. So and so greatest. Okay, just 1 by square root of something. So 1 by square root of something means it should always be only positive. Minus 3 times of step of x minus 10 should only be greater than 0. So step x whole square, we can factorize this, plus 5 times of step x minus 5, because we need minus 3 now, minus 5 times of step x plus 2 times of step x minus 10 greater than 0. So we can write step x minus 5 into step x plus 2 greater than 0. So clearly step x less than minus 2 or step x greater than plus 5. So clearly if step x less than minus 2 means, x belongs to step x less than minus 2. So x belongs to minus infinity to minus 2. Okay. Union step x greater than 5 means closed 6 to infinity. So this is the domain of the given function, which is option B. Option B is the correct answer. Next question. For x belongs to capital R, two real valued function f of x and g of x, such as g of x is equals to root x plus 1 and f circle g of x is equals to x plus 3 minus 3 root x, then f of 0 is equals to. Friends, they have given f of g of x and they have given g of x. They are asking us to find f of x. First, you should know how do we get f of x from f of g of x. Let's see this. So f of g of x is now f of root x plus 1, we have to express this x plus 3 minus root x in terms of root x plus 1. Let's see something. Root x plus 1 whole square. What is root x plus 1 whole square? Something x plus 1 plus 2 root x. X plus 1 plus 2 root x. But we have minus 3 root x, no? So that for that minus 3 times of root x plus 1. See? Minus 3 times of root x plus 1. Root x plus 1 whole square is x plus 1 plus 2 times of root x minus 3 root x minus 3. We have got now finally what we have got, x 2 root x minus 3 root x is minus root x, minus 3 plus 1 is minus 2, but we need plus 3, no? So let's add plus 5 here. That's it. See friends, we have got f of root x plus 1. We have expressed this x plus 3 minus root x as root x plus 1 whole square minus 3 times of root x plus 1 plus 5. That means clearly what is f of x? F of x is equals to x square minus 3x plus 5. That's it. Okay. Now they are asking f of 0. So f of 0 is equals to 5. One single answer. Answer is 5. Clear? Next question ma. F mapping from r minus 0 to 1, r minus 0 comma 1 to r be a function such that f of x plus f of 1 minus x, f of 1 by 1 minus x is equals to 1 plus x, then what is the value of that? Okay. Friends, first let's find what is, put x is equals to 2. If we put x is equals to 2, f of 2 plus f of 1 by 1 minus 2. 1 by 1 minus 2 is minus 1. F of minus 1 is equals to 1 plus 2, 3. Put x equals to minus 1, the value which we are getting here. When you put x is equals to minus 1, f of minus 1 is f of minus 1 plus 1 by 1 minus minus 1, that is f of 1 by 2 is equals to 1 minus 1, 0. We are getting 1 by 2, no? Put x equals to 1 by 2. F of 1 by 2 plus 1 minus 1 by 2 is 1 by 2. 1 by 1 by 2 is 2. See, we have got this. That is 1 plus 1 by 2 is 3 by 2. Simple friends. Now add these two, then subtract this. Add these two, add first and last, then subtract this. Clear? Let's see. Now add these two equations. F of 2 plus f of 2 is 2 times of f of 2 plus f of minus 1 plus f of 1 by 2 minus middle one, f of minus 1 minus f of 1 by 2 is equals to 3 plus 3 by 2. F of minus 1, f of minus 1, f of 1 by 2, f of 1 by 2. So 2 times of f of 2 is equals to 2, 3, 6, 6 plus 3, 9 by 2. So finally friends, f of 3 is equals to 9 by 4. Answer is 9 by 4. Next question. The equation x square minus 4x times 4x plus step x plus 3 is equals to x into step x where something. First let's try to rearrange this expression. Okay. For that x square minus x into step x, get this to the other side, minus x. From minus 4x, what I am doing, minus x plus step x, we have minus 3x plus 3 is equals to 0. See, from these two I have taken x common, so x minus step x. From these two I have taken minus 1 common, x minus step x, minus 3 common, x minus 1 is equals to 0. We know x minus step x is fractional part of x. So x into fractional part of x minus fractional part of x minus 3 times of x minus 1 is equals to 0. We can take fractional part of x common, fractional part of x minus 1 minus 3 times of x minus 1 is equals to 0. Now we can write this as fractional part of x minus 3 into x minus 1 is equals to 0. So fractional part of x is equals to 3 or x is equals to 1. See friends, Fractional part of x is something which lies between only closed 0 to open 1. That means it is not possible. So x equals to 1 is possible. That means there will be only one solution throughout R from minus infinity to plus infinity. Only x equals to 1 is the solution for this. Clear? Next question. F of x is equals to 2 power 2x divided by 2 power 2x plus 2 x such that x belongs to R, f divided by 1 and so on till 2022 divided by 2023. Friends, whenever we come across a question such that a series problems, please make sure you identify a pattern. See, before this you will be having 2021 divided by 2023. If you sum these two, you are getting 1. If you are sum these two, you are getting 1. That means you have to find the value, you have to find the function such that f of x plus f of something, if you add, like if the inputs, if you add two inputs, if the sum of two inputs is 1, for those what is the output value? That means, see, they have given f of x is equals to 2 power 2x means this is 4 power x divided by 4 power x plus 2. Now, I said you have to sum two functions such that input is our input. See, 1 plus these two. If you add these two, you are getting 1. That means you immediately find f of 1 minus x also. Okay. Now, what is f of 1 minus x? F of 1 minus x is 4 power 1 minus x divided by 4 power 1 minus x plus 2. Now, let us see this. Simplify this. F of 1 minus x is equals to 4 power 1 minus x is 4 divided by 4 power x, 4 divided by 4 power x plus 2. We can write this as 4 plus 2 into 4 power x by 4 power x. We can take 2 common. So 2 divided by 2 plus 4 power x. Okay. Now, this is what our f of 1 minus x. So clearly friends, if you see this, f of x plus f of 1 minus x is equals to 4 power x by 4 power x plus 2 plus 2 by 4 power x plus 2. So this is 4 power x plus 2 divided by 4 power x plus 2 is equals to 1. That means whenever you add two functions such that their input sum is 1, you will be getting the result as 1. So see, f of 1 by 2023 plus f of 2022 divided by 2023 will be 1 plus f of 2 by 2023 plus f of 2021 divided by 2023 is again 1. Okay. So you will be getting how many for each, how many total expressions? 2022. Okay. Of those, for each sum of two extremes, you are getting 1. That means half of the value you will get. So 2022 divided by 2, which is 1011 is our answer, ma. 1011, because sum of these two is 1 plus sum of these two is 1 plus 1 plus 1 plus 1 plus 1 plus and so on. How many times? 1011 times. You will be get that many pairs. Each pair the value is 1. Next question. F of x be a function such that f of x plus y is equals to f of x into f of y. First you have to understand this is standard functional equation, friends. I have given already standard functional equations. If f of x plus y is equals to f of x into f of y, such function is called as exponential function. So a power x plus y, we can always write it as a power x into a power y. That means here f of x is equals to a power x. That's it. Next, this is the most important part. They have given f of 1 3, that is f of 1 is equals to a power 1, which is 3. So a is equals to 3, friends. Okay. Now they have given sigma n k equals to 1 to n. So f of 1 plus f of 2 plus f of 3 and so on. F of n is equals to 3279. What is f of 1? 3 plus 3 square plus 3 cube and so on. 3 power n is equals to 3279. Friends, this is clearly a GP. In geometric progression, some formula is 3 into r power n minus 1 by r minus 1 is equals to 3279. 3 1 ja 3 1 ja 3 3 9s are 27, 3 3s are. So 3 power n minus 1 is equals to 1093 times 2 is 2186. Now 3 power n is equals to 2186 plus 1, which is 2187. 2187. 2187 we can write it as 3 power 7, friends. So hence the answer is option C. N is the value of n is 7. Clear? Next question. F of x given 2 into x power n plus lambda, f of 4 given, f of 5 given, then the value of then the sum of all the positive integer divisors of f of 3 minus f of 2. First we do one thing. We will subtract f of 5 and f of 4. F of 5 minus f of 4 is 255 minus 133. 255 minus 133, which is 122. Which is 122. Now what is f of 5? F of 5 is 2 into 5 power n plus lambda minus 2 into 4 power n minus lambda is equals to 122. Lambda cancel. 2 times of 5 power n minus 4 power n is equals to 122. So 5 power n minus 4 power n is equals to 61. Clearly n is equals to 3, friends. See, if n is 3, 5 cube is 125. 125 minus 64 is 61. So clearly n is equals to 3. Now we have got n is equals to 3. Fine. What is f of 3 minus f of 2? Same story. F of 3 minus f of 2 is 2 times of 3 power 3 minus 2 power 3. Correct, no? Correct only. So 2 times of 27 minus 8, which is 2 times of 19. 19 2s are 38. Now they are asking sum of all positive integer divisors of this 38. What are all the integer divisors of 38? 1, 2, 19, 38. That's it. So 20 plus 40, which is 60. Sum of all of them is equals to 60. Answer is option B, ma. Clear, friends? So friends, with that we are done with super questions from the chapter functions. I am very sure that if you are able to do all these 26 questions and if you are able to analyze the pattern that we applied in all the 26 questions, we will be in a situation to do any question from the chapter functions. I have included good questions based on functional equations, good questions based on composite functions, and good questions based on 1-1, determining whether the function is 1-1 or not 1-1, 1-2 or not 1-2, a bijective function also. Inverse functions also have taken. Okay. So with that, I am done with the PYQs from the chapter functions. See you in the next session. Till then, all the very best, friends.